Hello everyone, welcome to Applications Manager's free training series on applications performance monitoring. So let's quickly jump into today's agenda. So we are going to cover a total of four parts. In the first part, we will discuss and understand the application performance with APDEX scores. In the second part, we will explore how you can monitor code flows across applications via distributed tracing. In the third part, we will be looking at how you can directly pinpoint the problematic elements in your application code. At last, we will visualize the dependent your application architecture with the help of automated steps. Before discussing the topics in the agenda, let's start with why application performance monitoring is required. Here, just imagine a user who is accessing an e-commerce website and trying to purchase from the online store. Adding the required items to the cart, they are trying to place the order. Now, at the time of placing the order on the payment portal page, they encounter issues like the portal might take a long time to load, or getting redirected to a blank page, or facing some error codes while adding the product to cart or completing the payment section. So, this kind of operation could result in potential customers being unable to access the application, being going to be a huge business loss for the company. So additionally, developers working on the web application may struggle to identify the root cause of this type of issues. As the demand for applications has increased, the complexity of its development has also grown. So therefore, it is essential for developers to ensure that the website is bug free and capable of handling the database load efficiently in order to provide better service to the users. So to make it happen, observability is necessary here. In order to understand that, here are some of the contemporary trends in application monitoring. The first trend is cloud native applications. Many large enterprises are moving their applications to the cloud. So these applications use microservices such as Docker and Kubernetes, which may help them to have a scalable, flexible, and efficient environment. So developers and operation teams follows DevOps practices to deliver software very faster nowadays. So monitoring here is very important in order to track the each component and ensure the application can handle a large number of users. The second trend is the use of artificial intelligence for IT operations, which is AIOps. So AI and machine learning will help you to detect the unusual system behavior, automate the IT tasks, predict future issues using the historical data, and optimize the resource usages based on the real-time performance. And the third trend is the user-centric monitoring. So this approach focuses on the end user experience by tracking the user journey by accessing the application to completing tasks. So it measures page load time, response time, and the overall responsiveness to improve the user satisfaction. The fourth trend is application observability. So it provides deep insights into application performance and health by analyzing logs, traces, execution time, and transactions as well. So this will help you to identify errors, bottlenecks, and inefficiencies in your application code. The final trend is the full stack performance monitoring. So it monitors the entire application stack from the front end interface to the back end servers along with the databases. So real time data such as the response time and error code are used to detect and fix the performance issues quickly. So as we discussed in these types of trends, right? So by adopting these modern trends, organizations can monitor the applications in real time, identify issues early, and ensure better reliability, availability, and user experience. Further moving on, the traditional application trends were usually hosted on the on-premise servers or in a single data center. So which is the traditional applications. So this might often cause some high downtime, limited availability, and performance issues during peak time traffic. So, scaling required purchasing new hardware, which involved a high cost and long setup time as well. So, maintenance was also very expensive because physical infrastructure needed regular updates and repairs. So modern applications use cloud computing and containerization to improve availability and reliability. So features like load balancing, redundancy, automatic failover, and global distribution help to reduce downtime and ensure smooth user experience. So cloud platforms allows a flexible scaling based on the demand, reduce upfront cost, and improve resource utilization through automations. So as I mentioned, as we discussed in traditional systems, the content delivery was limited to specific locations, which caused latency for users in other regions as well. So modern solutions use content delivery networks and edge computing to distribute content globally. So this reduces response time and provides faster, more consistent performance for users across the globe. So operational efficiencies was low in traditional approaches because deployment, scaling, and maintenance were done manually. Here, modern DevOps practices such as CI/CD, infrastructure as code, and container orchestration automate these processes. And microservices architecture also improves flexibility, allowing updates without the downtime. So overall, modern application development offers better availability, lower cost, faster global delivery, and improved efficiency compared to the traditional methods. And these benefits help businesses stay competitive and responsive as per the changing demands. Here, several key factors plays an important role in determining the performance of an application. The first factor is the response time. So when a user performs a transaction in a web application, the request travels through a network and application layer to reach the server. And the response time is then sent back to the user, and that response time refers to the total time taken from the sending the request to receiving the final results. So here database query response time is also critical, as slow queries can significantly reduce overall performance. So application response time includes processing delays, network latency, and system load. Another important factor in application code is the bugs, inefficient logic, and excessive exception handling can cause unexpected behavior and performance degradation as well. So here, frequent errors often indicate deeper issues in the code. Stack traces help to identify the sequence of function calls that led to an error, which may make it easier to locate the performance problems. Further, moving on, memory usage is also crucial. High memory consumptions can slow down the application or even cause crashes. So memory leaks occurs when the application does not release unused memory properly, which may lead to increasing the memory usage over time and reduce the system stability. So finally, the database plays a major role in the performance area. So where slow queries and too many database calls can affect application responsiveness, optimizing queries and reducing the unnecessary database interactions can greatly improve speed. In conclusion, monitoring response time, code efficiency, memory usage, and database performance is essential for maintaining a smooth and reliable application. So regular performance testing and tuning help you to ensure consistent and efficient operations. So now let's see how the APM Insight functions. So the application performance monitoring insight is the add-on feature that uses an agent for monitoring in the application. The initial step will involve deploying the agent onto the servers where the applications are running. These agents are responsible for gathering the performance data and transmitting it to the applications manager for analysis. The agent within the application server utilizes a bytecode instrumentation technology to track the individual user transactions as they navigate the application step. Then it will send this transaction data to the applications manager at a fixed time interval. So the approach will enable the detailed monitoring of the transaction performance, facilitating an identification of the bottlenecks or any performance issues available. So the tool will offer code level visibility, allowing monitoring of slow database queries and their performance by capturing the real time user interaction with the application. So users can configure any alerts and notifications based on the predefined threshold for the metrics that impact their application's performance. When the application performance reaches its threshold, the tool will send an alert to its IT team. So this alert system will help the developers and the IT team to pinpoint the areas that require improvement in performance, such as application code, database related issues, and the page load times. So this proactive approach help to address the issues promptly and minimize the downtime. So here, these are some of the key performance indicators in APM Insight. The first one is the APDEX score. APDEX is a numerical measure of user satisfaction with the performance of applications response time. The second one is the response time. It measures the average time taken for an application to respond to the user's request for the transaction across the applications as well. So lowering the response time is generally more desirable for the users and the application owners. The third one is the request, which is a total number of requests made to the application within the specific time frame and helps to decide the overall workload and the usage of the application. The fourth one is the data throughput. It indicates the amount of data that is transferred in bytes or processed in and out of the network request by the application during the monitoring period. So which will also help you to understand the application's data handling capacity. The fifth is exceptions. It will track the number of exceptions, errors, or the failures that occur during the cycle of the transactions in a chosen duration process of the request. So these exceptions could be in various types of errors, such as the server errors, timeouts, or other issues that affect the application's normal operation. Here, so far, we have discussed why application performance monitoring is necessary. Now we can achieve this monitoring in Applications Manager with the help of APM Insight. So this APM Insight feature will give you the understanding on the way of how your application is behaving for the end users who are all accessing it with the help of the end-to-end transactions. So with this help of the end-to-end transaction monitoring across your web application, it will definitely help you to avoid any performance issues that is going to occur. So you can analyze the root cause of the problems much faster by performing the first level of troubleshooting. The supported technologies in APM Insight are Java, Node.js, .NET Core, Microsoft .NET, PHP, Ruby Rails, and Ruby Rails and Python. So if your application is built in any of this platform, so it is good to go for the monitoring in Applications Manager. Now let's understand the application performance with the help of APDEX scores. The APDEX score is categorized based on the application responsiveness. The first one is the satisfaction. So this category represents the highest level of user experience, where the application's response time is between the satisfied threshold and the excellent threshold. The users in this category are generally satisfied with the application performance, and the second one is the tolerance. The tolerance category indicates that the application's response time is between the tolerating threshold and the satisfied threshold. So users in this category might tolerate the performance but may not entirely satisfied under the same like the satisfied category users. The last is frustration. So this category represents the lowest level of user experience where the application's response time is below the tolerating threshold. So users under this category are more likely to be frustrated with the application performance as it does not meet their expectations. So this application performance index or the APTEX score is a standardized metric that is used to measure the user satisfaction and the application response time. The APTEX scale ranges from 0 to 1, where being 1 is the best score and representing excellent user satisfaction. So based on the total samples that are collected, the APTEX score is calculated as the sum of the satisfied plus half of the tolerating count. So over the total samples that are collected during the transaction. So using this formula, we are calculating the APTEX score. So based on this, we are going to provide the data, whether the users, based on the transactions that was made, whether the users are satisfied, tolerating, or frustrated. So here, Monitoring application performance using the APDEX score provides several important advantages. The first, it offers a new user-centric way to measure performance by showing how application behavior directly affects the user experience, and this helps teams to understand which areas need improvement to increase the user satisfaction. Second is the apdex second apdex simplifies complex performance data into a single easy to understand metric. So this standard measurement makes it easier to assess application performance without analyzing the large amount of technical data. Third, APDEX allows organizations to benchmark and compare the performance of different applications. This helps identify the high performing systems and encourages consistent improvement across the IT environment. And the fourth is the AppTex supports proactive issues identification and code optimization as well. So when performance drops below acceptable levels, low AppTex scores highlights critical transactions that need attention. So alerts help for teams to quickly detect the issues and focus on the improving key areas that where the users are got impact. Finally, historical aptex trend data that helps you to analyze the performance patterns over time. So this makes it more easier to track improvements, identify recurring issues, and maintain a consistently positive user experience. Okay, further, all the transactions would be captured among which you will select the key transactions, and then it will be available for monitoring, and you can refine those business transactions as well. Along with that, further, by marking the important key businesses transactions, the administrators can configure the thresholds and alarms using the transaction threshold support. So, which will help you to view the health status, performance, the root cause analysis, and track performance metrics. So, which will eventually ensuring that the most critical application parts are received timely attention and actionable insights as well. So now let's see how to monitor the code flows across the applications via distributed tracing. So in microservice architecture, if you take the microservices architecture, so it is necessary to monitor the transactions made between two or more applications or services. So with the distributed tracking tracing, feature, so you can track the transactions made between two or more applications as well. So distributed tracing tracks how a request flows across multiple applications. When an application makes an API request to another application, APM Insight adds an HTTP header containing the tracking metadata. So if APM Insight is enabled in the receiving application, it reads this header and returns the tracking information in the response headers. So if that application calls another service, the same header is passed along, allowing the entire request path to be traced across the distributed system. So using this data, teams can monitor when the transaction started, how long it took to respond, and which application and the transactions were involved. By expanding the application view in the interface, developers can see the detailed method calls and code blocks that consumed the most time. So this helps to identify slow components, track inter application calls, and we can able to quickly pinpoint to the performance issues as well. Now let's see the pinpoint how we can pinpoint to the problematic elements in your application code. The first thing is we need to eliminate the issues in the problematic code. So as you may aware, stack trace represents the moment of an application during the execution of a program. So when the Java application throws an exception, the stack trace gets locked within it. So by enabling the stack trace provided by APM Insight, the developers can pinpoint the exact line of the code and the sequence of the function calls leading to the issue. We have Along with that, we have introduced the milestone feature in APM Insight that allows you to create, manage, and analyze performance milestones for your applications. So you can now create milestones to capture and compare application performance data on specific dates. For example, that could be around any key events or any releases or any patchings that is going to be happen in your environment. So this helps you to evaluate the impact of the recent deployment or configuration changes that occurred on your application behavior. Also, you can analyze your application performance trends effectively by comparing the metrics across the two chosen dates using the compare view feature in the APM Insight. So this feature helps you to identify recurring errors, detect potential bottlenecks, and understand variations in key performance indicators over time, which may enable you to make informed decisions to enhance the application stability and performance. So going to the last slide, we are going to see how you can visualize the dependencies in your application architecture with help of the automated service map. So what is a service map? The service map will provide you a complete overview of the application infrastructure along with the connection to other dependent resources. So the main purpose of a service map is to identify the status of the application and its related instances. Along with that, it will monitor the key metrics like the response time throughput, and the status of the connection, and detect and troubleshoot any application problems before the customers are got impacted. So, and also to identify the number of failed requests, also we can use the service maps. So here is the map view. It will provide a way of analyzing the topological view of the application along with the its instances represented in the central node. Also, we have introduced the RAM analytics feature in APM Insight, which will provide real-time insights into the user interactions, allowing businesses to monitor and optimize application performance effectively. By tracking key metrics such as response time, page views, JavaScript errors, and geographic performance trends, it helps to identify slow transactions, errors, and performance bottlenecks across different devices and locations. This data enables organizations to proactively optimize their application behavior, ensuring a seamless user experience and improved overall performance. Also, we have the application dashboard in the applications manager that provides a comprehensive view of the application performance and user experience by combining the data from the APM Insight and the real user monitoring, which is going to be the front end performance monitoring. So by combining this, it will integrate. This integration will allow and provide a unified summary of both backend and user level performance, helping the IT teams to monitor key metrics such as APDEX score, user sessions, failed requests, slow transactions, and error reports into a single dashboard. Then we have the auto scaling feature, which is an automated way of managing the resources of your application. Imagine you have a website or an application running on a cloud environment. Whenever the application automatically scales up due to the high user interaction on the site, and to handle its extra traffic, a new instance will be created. However, when these applications are scaled down due to fewer user transactions or interactions, this newly added instance will become unused and it's still retained. The instant is going to be retained anyway, even your applications are having some low transactions as well. So this will lead to the license being consumed by the unused instances, which may resulting in the new instances or not being added for monitoring. Hence, with the help of the auto scale mode in APM Insight, you can now overcome this scenario by automatically unmanaging or deleting the unused instances in the cloud environment. Next, moving forward, we have revamped the Add Monitor page for APM Insight to simplify the onboarding process, which will making it more reflexive and user friendly environment. So now with this structured step-by-step guided flow in the UI, you can now effortlessly configure the APM Insight monitoring setup. We have the application level alarm metric feature introduced, which will allow the users to configure alarms using a more granular set of performance indicators at the application level. So previously we have it for a instance levels. Now this feature has been introduced under the application level. So this enhancements provides the precise monitoring by enabling users to select a specific monitor and associate thresholds with key attributes. By setting alarms for this application level metrics, businesses can proactively track performance deviation, identify potential issues, and optimize application behaviors more effectively. Added to these features, so we have introduced the app logs monitoring, which is a log management feature. So, and also it enables you to collect the log and ingest, search, and analyze the logs from the applications and the servers through a single unified search interface. So logs are collected using the applications manager FSO agent, and those will be presented in a centralized view, which will be easier to correlate and analyze the log data across your environment. So in a single interface, you can monitor the logs of your applications, and you can have the multiple logs being monitored in your application into a single unified device. Let's see what is a log type. A log type defines the format in which an application writes its log. Different applications such as IIS, uh, Apache, and MySQL generate logs in different formats. So defining these formats as log types helps app logs correctly parse the log entries. So group logs from similar applications and enable faster and more accurate searching as well. So if an application log format is not available by default, no issues. So you can create a custom log to a custom log type to suit your log environment. And this app logs includes 60 plus predefined log types for commonly used platforms and services, along with the custom log types that help you to define log formats for applications or services that generate logs in non-standard and unique formats. Further, we have a log profile that associates a log type with specific log sources such as filters or directories. So using log profiles, you can effectively manage the log collection across multiple servers and applications as well. So now let me take you to the applications manager user interface and show you a quick demo on the APM Insight monitoring features. I hope the applications manager user interface is visible now. Let's start with the onboarding. As you may aware, this is how the applications manager user interface looks like. And we are coming here, clicking on the add new monitor. On the left side, we have categorized the complete monitoring types that is available for monitoring. And now we are going to onboard the APM Insight. So as you can see in the APM Insight tab, the supported platforms are available. Let's say we are going to onboard a Java application. So we are going to click on the Java application over here. So this is a revamped user interface that I mentioned in the slide. So here you can choose the deployment type. So whether the application is deployed on the host or a container. So if you are choosing the host, you can define which host it is, whether it is any Linux distributions or in a Windows server. So if I choose a Windows server, we can choose the framework of your application. It could be a Tomcat application, it could be a JBoss application, it could be Oracle WebLogic applications, so it could be a Wi-Fi application. So you can choose a framework in where your application is built in. So let's assume it is a Tomcat application. So I'm choosing a Tomcat as a framework. Now I'm going to the next step. So we can name the application. So in the applications manager under the APM inside. So what you want to call your application. So it could be a e-commerce application, could be a banking applications or any other own in-house application. You can provide any simple name for display, and you can provide the port in which your application is being running, and you can choose the Java version as currently we are onboarding a Java application. So once after that, we can go to the next. So the next step is going to be a prerequisite. A simple prerequisite is enough. So it's going to be the connection between the applications manager server and the application server should be reachable. So that is the prerequisite one. The second one is going to be the PowerShell script execution permission. So we need this, PowerShell permission in order to execute this command. So we can copy this command. You can provide a direct execution on your PowerShell in the application hosted machine, which is a Windows machine over here. So once after that, the arguments will be configured and the monitor will be added as expected. On the right side, as you can see, these are all the application servers that is currently being supported, and these are all the frameworks that is being supported. And when it's come to the database for your Java application, if you are using any one of these databases, so that is enough in order to fetch the database queries. And these are all the components that is currently being supported as well. Yeah, that is being supported as well. And if you're using any cloud VM, so we can have this, if you are hosted in any of this cloud VM, so these are also supported. So now we have successfully added the monitoring for the APM Insight for monitoring. So now uh, under the APM tab, so once it is onboarded, it will be available under the APM tab. This is how your onboarded applications will look alike. So let's assume this is the Java application that we have onboarded. So on the overview, it will showcase the APDEX scores, the errors, average response time, and throughput over here. So I want to see the in-depth information. So I'm just clicking on the Java application. So this is the overview. After selecting the overview, here I can see the APTEX score, and this is the APTEX score that we discussed in the slide as well. So based on the response time, as you can see here, I can sort out the time frame. So in the last 30 minutes, whatever the transactions that were recorded from the user perspective, so whatever the transactions that were made from the users, those transactions for the last 30 minutes will be recorded, and the performance metric of that transactions will be shown over this breakdown. So as aptex score, as I mentioned, based on the response time for the last 30 minutes, this will be shown. So based on the transactions over the last 30 minutes, we can see that only 73% of the users were satisfied, 25% of the users were tolerating, and around the 0.3% of the users were frustrated. So we can drill down into these in the upcoming, I will show you how to drill down into these to identify the frustrated and the tolerating users transaction and which transaction exactly that difficulty were captured. And requests. So in 30 minutes, how many requests has been captured? So totally 1504 requests has been made, and in that number of requests, how much percentage has been captured? So these types of requests will help you to scale your application. So based on the high volume or high request that is being received in your application, so you can able to scale your applications as well. And errors, so what are all the errors that is being captured, and what are all the exceptions that is being captured, and what is the data throughput within your application? So these are all the golden metrics that we showcase. So now in your application you may have thousands of transactions that is being performed every day. So if we can able to monitor those all the transactions, but as application owner we need to make sure what are all the application transactions that is causing a high response time. So as I mentioned, any application, any transaction that has a high response time, it's going to be uh, a deal breaker for the users, right? So in order to check that, if we scroll down, we can find the top 5 transactions by response time. So comparatively, in the last 30 minutes, these are all the top 5 transactions that is having the high response time. Now we can drill down into this transaction by simply clicking on the transaction, that specific transaction. It will take us to this specific transactions tab, and this is the transaction. We can able to see the performance or golden metrics over here as well. So what is the APDEX score for that transaction? And this transaction is being taking 1.24 seconds, and only 33 requests were made. But in that 33 requests, each transaction is going to take around 1.24 seconds of the average time. And what is the exceptions that has been captured? So if we scroll down along with that, we can see the complete recent traces of the transactions. With the help of these traces only, we can able to identify the code level stack. So I will show you. And if we scroll down, we can see the response time by components. If we hover to any spike or any specific time frame, we can see on this specific time frame, there is a HTTP call was occurred, and the application code execution is taking around 6,468 milliseconds. No GDBC transaction will happen, and the overall response time is going to be the same. So, and you can have the split up over your app server component as well, HTTP call and the app code as well, and the request throughputs, data throughputs, all these performance metrics can be captured along with this graph. So now I want to drill down into the code level stack to identify which low code level or the DB call that is making this specific transaction to have around 1.24 milliseconds of or seconds of average response time. So I'm just clicking on the specific traces. So here we can see the complete code level stack over here. As you can see, so in order to complete this transaction, it is taking around 36 method calls and one SQL DB calls in order to make this transaction to be work as expected. So in this 36 method calls, if we click on the suspected slow metric trace, right? So these are all the stack trace that is taking the high response time. So we can take a screenshot of this, and we can copy this. We can share this information with our application development team, so they can make necessary changes in the code level to provide the better experience for the users. And similar to that, you can see what are all the attributes that are being requested for the application. And as I mentioned, there is one SQL call is required, right? And this is the SQL call that is being mentioned. And along with that, if there are any external remote calls that is being communicated within your application, it may be due to any microservices. You can see what are all the external calls which is being talking with each other, and if there are any exceptions has been captured along with the time frame. You can find the exception details over here. If you click on the exception class over here, you can see this stack trace as well. So you can share these types of informations with your application team, so that they can make necessary changes to for optimizations. So basically, you are doing these changes. You are identifying the code level stack, the everything over using our application. So you can provide the better experience for your application in the long run. So what are all the other transactions that is taking, and under the JVM, you can see the JVM usage of your application as well. So on this note, for these transactions, so we have started from the overview. So we have found what are all the transactions that is being taking more response time. We have trying to drill down into the transaction. We identified these are all the traces that is taking more, making this transaction more response time. So we are drilling down into the transaction to see what are all the stack trace. So with the help of these stack trace, we can able to analyze and optimize the application. Along with that, we have a complete database tab over here. In this database tab, we will collect the complete queries that are database operations that is being executed on your database. So in the last 30 minutes, these are all the database operations that has been occurred in your application. So we can drill down into here. We can just sort down using the average response time. So if by sorting out this, we can find what is the specific database query that having the high response time. So let's assume currently 0.36 milliseconds is fine, but let's assume this database query having the high response time. So by drilling down into the database query, we can see if there any errors were occurred during that database operation, in what are all the transaction that is being used with this query. So what are all the transaction this query is being communicated. So you can see the list of transactions and over here, and this transaction is currently being reviewed over here. And what is the database operation response time, and what is the database operation throughput, those details can be seen over here. So under the JVM tab, we can see the complete JVM details, like what is the JVM usage, and what is the threads JVM things that is having the more response time. Those details can be available. And under the configuration, we can see what are all the classes were loaded and what is the classes were unloaded, and what is the heap memory that is being associated, what is a non-heap memory, and the complete host details of your application will also be uh, sent over here. So along with this, yeah, we can move to the exceptions tab. So under this exceptions tab, we can see what are all the top exceptions that has been captured in the last 30 minutes, and top error codes. It could be a 404 error, it could be a 400 error, 503 error. How many errors were captured? You can see the count over here. So if you want more drill down details by clicking on the 404, we can see in what are all the transactions this error were captured. So as you can see, this 404 error were captured by while the users are accessing the specific transaction. So as around 28 times this error has been populated in the last 30 minutes. So this is for the error codes, and these are all the exceptions. So you can find what are all the exceptions has been identified, and in which transaction those exceptions were captured, and what is the collection time of that exceptions. And along with that, we can see the recent exceptions and the recent transaction traces, what is the error count in that exceptions, and what is the transaction split by the exception count. By hovering to that, we can see with the transaction level exceptions count as well. And moving on to the service map, so this is the specific feature that I want to highlight over here. As I mentioned, so you just let's assume this is your e-commerce application. Your application might have multiple microservices or multiple components that is being associated. So by looking at this page, we can see what are all the components that is being associated with your application. So let's assume currently the database is being down, it's been crashed. So in order to what the application is being crashed, and that might be due to the database issues. So in order to checking with the multiple teams, we can directly come here by checking the service map by hovering to a specific component. We can see the health of the component and also the performance of it. Now, how many requests this component is making with the application, what is the failed request, what is the total request, what is the average response time of each component can be captured. So if any component goes down, so this status will be turned into a red. So you can directly reach out to the specific team or raise a specific ticket in order to work with the team to bring back your application up. And this is how the service map feature used. And we have the map view and we have the table view as well. So with the help of the table view, so we can see what are all the currently there is a HTTP call component, and what are all the features that is being associated for that specific component as well. And we do have the app parameters. So by default, we are monitoring the JVM parameters. So if you have, and if you want to, monitor any custom parameter, app parameter from your application, so you can configure that as well to monitor the performance of it. And we do have a thread profiling, so it can be created on demand. So you can make a specific thread time, and you can create a thread collection over here. So this is one of the thread that has been captured on this specific time frame. So here you can see what is the CPU time, what is the thread count, how much memory that has been allocated for that specific thread, and what is the profiling to relation. So profiling duration is minimum, it's below 1 minute only. So here you can see the top threads along with the thread IDs. And if I, use the drop down of this specific thread, it is taking around 178 memory that has been taking. And the CPU time is fine. And if you see, these are all the stack trace. So if your application, production application, having the high CPU time for this specific thread, or the memory allocated is being accumulated more, in that case you can come here to analyze that the stack trace. So which stack trace that is having the which stack trace that is making that specific thread to have the high CPU time or the memory allocation time. So by having this thread count, you can able to optimize your performance even more. And this is the milestone feature that I mentioned. So using this milestone feature, so we can able to analyze the before and after data. So let's say today your application is going to have a server is going to have a patching. So Windows patching, let's say. So you can create a milestone today, and you can capture the performance. And let's assume tonight the application patching has been completed. So tomorrow you can create another milestone. So you can create another milestone tomorrow, and you can compare both the performance, so before patching and after patching. So how your application behaves before patching and how your application behaves after patching. And along with that, so as I mentioned, so we are providing the RAM analytics feature over here. So RAM analytics is nothing. So you will be having a detailed discussion of this RAM analytics in the upcoming digital experience webinar. So RAM analytics is going to be the complete front end performance, track of your application. And and as you can see, it will show a combined user experience data over here. So it will going to show the APDEX score, response time, page view times, and the JavaScript errors. So these page view times and JavaScript errors are captured from the real user monitoring. So you can see the average response time taking from the browser. And yeah, so this is how the real user monitoring RAM analytics also works. So if you are added the same application for the front end performance monitoring, in that case you can able to use this RAM analytics to have the combined front end and back end performance. And adding to this, we do have the application dashboard over here. So yeah, so if I click on the e-commerce application dashboard, so it's going to view the complete data. So this data is a combined for the real user monitoring and the application performance monitoring. So it show the our performance APDEX scores, and how many user sessions in the front end level has been captured. So this is on the back end, how many requests are getting failed, and what is the top slow transaction has been occurred, and what is the errors has been captured. And in the summary report you can find in what are all the regions, this is comes under the user monitoring. So what are all the regions your application is being accessed, and what is the response time of that each region. So which region behaves more when it's come to the performance. You can have this combined data. And along with that, as I mentioned about the application alarm configurations under the application level. So you can click on the alarm configure alarm, so you can go to the monitor type over here, and you can choose the APM inside. See, you can see the application and instances. If you want to uh, make the configure alarms for any of the instance, you can probably go with the instance, or you can go with the APM inside application level. So it will provide the complete, mark up the complete application performance metrics like here. So it could be AppDex score, response time, the tolerating percentage in the AppDex score, the errors. So let's say you do not want the Java CPU usage not to be breached up to a certain level. So for that specific application, if you want to get notified, so you can associate the alarms, or you can create any thresholds as per your recommendation, as per your requirement. It could be above 80 percentage or 90 percentage. Then you can get the notifications in the term of email, SMS, trap actions, or and any ticketing action, Slack action, anything like that as per your requirement. And that's how come to overview of the APM Insight looks like. So now let's quickly jump into the slides. And yeah, so now let's have a quick recap. So yes, so in the first part, so we have discussed on how to track application performance using the AppDex score. And next we have explored how to identify the problems in the application code. In the third segment, we saw how to track the transactions from one application to another and debug the issues. In the last part, we have encircled identifying problems in the code by concluding and discussing on how the service maps makes it easier to identify the problem. And if you would like to have a detailed personalized demo on the APM Insight feature to see how it works on your environment, so you can kindly hit the poll that is displayed on the screen. Our team will reach you out soon in order to schedule the demo at the earliest. Thank you everyone. We appreciate your time and participation. Have a great day.